So as I promised you, I'm going to teach you to complete the square in full generality for an arbitrary quadratic function. Once again, what I'm going to show you is going to look a little bit technical. I do not want you to memorize that. What I want you to do is I want you to train yourself to complete the square on concrete examples and memorize the steps towards completing the square, rather than the rather ugly formulas which I'm going to show you right now. So, to complete the square means to carry out the following algebraic manipulation. Let's take an arbitrary quadratic, ax squared plus bx plus c. So here's what we do. First, we factor out the leading coefficient. That's exactly what we did on the previous example. In the previous example, the leading coefficient was the number 3, if you remember. Okay. The next thing we do is we factor out the leading coefficient a from the term bx. So we get b over a. So in the preceding example, that was 5/3. If you remember, b was 5 and a was 3. Okay, the next thing we do is we multiply by 2 and we divide by 2. Okay, so the next thing we do is we add and subtract some magic constant so as to make this expression that we see here into a perfect square. Okay. What was that magic constant? Well, to remind you, the constant was determined like this. Take the number 2, take the number x, and whatever is left between the two of them, that's the number that we have to use. So the number in this case would be b over 2a. So the same number that we see here, that's the number we have to square, and that's the number that we have to add and subtract. Next, we use the fact that a plus b, the whole thing squared, is equal to a squared plus 2ab plus b squared. So, in this case, the letter x plays the role of a. So, the letter x here plays the role of the letter a. So, I'm having a plus b squared, and that is, a squared, and that's the number a here. You can see the same two positions for the letter x, and the letter b, the role of the letter b is taken by the expression b over 2a. Of course, b over 2a, the whole thing squared, is b squared over 4a squared. Okay, and just as in the preceding example, this is the bulk of the work when completing the square, but this expression can be transformed a little bit more by distributing the coefficient a out of this parenthesis. So we distribute the coefficient a to the two terms, and of course we notice that the letter a here is present both in the numerator and in the denominator of this fraction, so we can cancel here we have a squared, we can cancel one of the a's with this a here. And we're left with the final expression which stands for completing the square. So we're left with the expression a times x plus b over a squared plus c minus b squared over 4a equal to ax squared plus bx plus c. So once again, to complete the square means to carry out the transformation. Ax squared plus bx plus c equals a times x plus b over 2a, the whole thing squared, plus c minus b squared over 4a. Now you can see that this expression here is long and difficult to remember. So difficult to remember. So I recommend, rather than memorizing that verbatim, I recommend memorizing the steps leading to completing the square and carrying out those steps every time you need to complete the square. Now, I want to teach you one mathematical term, that of a quadratic polynomial discriminant. So what did we do in the preceding slide? We took the expression ax squared plus bx plus c. So we took that expression and we rewrote it. So we took ax squared plus bx plus c and we rewrote it to a times x plus b over 2a squared plus c minus b squared over 4a. So that procedure, transforming that quadratic here into this this expression, was called completing the square. That's what we just learned how to do. Okay, so we completed the square like this, but here's what we can do. We can rewrite this plus here into two minuses. Why you're going to say, well, why not? We're allowed to do that. So further justification why we'll do such a weird looking transformation will be given later. So let me just do it for now without explanation. And another thing which we can do is we could take these two terms that we see here and we could put them under common denominator. So how is that done? Well, minus b squared, I'm going to transform it into minus b squared here. And the number c, I'm going to multiply it by 4a. I'm going to divide it by 4a, so in this way I'd put these two in the common denominator. And the two minuses, they're going to give me a plus. So the two minuses here would give me the plus which stands in front of c. So I can transform c minus b squared over 4a into negative b squared minus 4ac over 4a. The next thing I'm going to do is I'm going to take this expression b squared minus 4ac. I'm going to take that expression and I'm going to give it a name. You'd say, why would I want to name such an expression? Well, because that expression is going to appear frequently when we deal with quadratic equations. So I'm going to now take the expression b squared minus 4ac and I'm going to name it. And I'm going to name it the discriminant. So that expression b squared minus 4ac, I'm going to name it discriminant. I'm going to denote that discriminant with a capital D, the capital letter D. And once again, I'm going to declare b squared minus 4ac to be the discriminant of the quadratic, of the original quadratic. Ax squared plus bx plus c. Okay? So once again, that expression here, b squared minus 4ac, is called the discriminant of the quadratic function. Okay, so we introduced the notion of a discriminant. Discriminant is simply a number, b squared minus 4ac. Whenever we have a quadratic function, its discriminant is b squared minus 4ac. Why would we care for that? Given a quadratic function, we saw that we can rewrite it in the form something, in this case a, times a square plus another constant. So we can rewrite a quadratic function into the a times something squared. So here we have something squared. That's the object that we see here. Plus yet another constant. So plus yet another constant here. Whoops, I said plus, so I should include the minus. So plus another constant. So what completing the square means is we're taking a quadratic function and we're rewriting it as a square times a constant plus another constant. So from the process of completing the square, we saw that if the quadratic is in the form a times x minus h squared plus k, then h must necessarily be equal to minus b over 2a. right, for that to make sense. And the number k must necessarily be equal to negative d over 4a. So the number k must be equal to negative d over 4a, where d is that magic discriminant, or the number k must be equal to minus b squared minus 4ac over 4a. Now, that expression, rewriting our quadratic function in the form, in this form, in the complete square form, so that form is called the standard form of the quadratic equation. So to complete the square means to rewrite the quadratic into standard form. Okay?